So this is question number 1 from exercise number 3.3, chapter number 3, circle. Now your question is, in the figure, points G, D, E, F are the concyclic points of a circle with center C. So G, D, E, F are concyclic. So we have already studied this theorem. Concyclic means when you join these 4 points, you will get a quadrilateral. And that quadrilateral is called cyclic quadrilateral because quadrilateral is completely inscribed within a circle. So on joining G, D, E, F, you will get a cyclic quadrilateral. That's why these points are called concyclic. With center C, so C is center of the circle, angle ECF, we're talking about this angle which is 70 degree, major arc DGF. So this bigger arc is of 200 degrees. Find the major arc DE. So you need to find out this arc DE. So in order to find the major arc DE, you need angle DCE. So if you have this angle, you can find out this arc. And then second we need to find out major arc DEF. So DEF, this whole arc. So it's simple. If you have this arc EF, so you can add arc DE and arc DEF to get the major arc DEF. So this is all about this question. Now let us start with its solution. This angle is already given as 70 degree, and this arc DGF is of 200 degree. So here I can say angle DCF is equal with major arc DGF, because this is in central angle DCF. I am talking about this angle DCF, and its corresponding intercepted arc is DGF. Since DCF, this angle is central angle, so its corresponding intercepted arc, measure of its corresponding intercepted arc in this central angle should be equal, and this is because of central angle theorem. So here you will write central angle theorem. Last time we already discussed this theorem, central angle theorem. So this way, if this arc DGF is of 200, this angle DCF will also become 200. So here we can write DCF is equals to 200 degree. Now, total angular measure of a circle is 360, and in this circle on the center we are getting 3 angles. So if I'll add all 3 angles together, the measure of all 3 angles should be 360 degree. So I'll write all 3 angles, angle DCF plus angle ECF plus angle DCE. Everybody track these 3 angles in your figure is equals to 360 degree. Reason, sum of all angles in a circle. Okay. So first is DCF. DCF means here we taking this angle D, DCF, this angle, plus ECF, this one, plus DCE, this angle. So on adding these three angles, it completes all the or entire angle of the circle, which should be 360 degree. So that's why we written this equation DCF plus ECF plus DCE is equals to 360 degree. Reason is sum of all the angles in a circle. Now this DCF is 200. So here I'll take 200 plus ECF. ECF is already given. Angle ECF is of 70 degree. So here I'll take 70 degree plus this angle DCE is unknown. So I'll write DCE is equals to 360 degree. Now this 200 plus 70 will give you 270. So this is positive 270, 270 plus angle DCE is 360. So you can send this 270 to the right hand side. So angle DCF is 360 minus 270. So this way angle DCF 0 minus 0 and then 16 minus 7, 9. So it is 90 degree. Angle DCF is a 90 degree. So this angle DCF is of 90 degree. Now we need to find out major arc DE. So this is major arc DE. So in order to find out DE, we need this angle DCF, which we have now. So here I can say major arc DE is equal with angle DCF. Same reason, central angle. So therefore, this DE will become same as DCF, which is 90 degree. So here you can write 90 degree. So major arc DE is of 90 degree. Now we need major arc EF. So DEF. So major arc DEF actually starts from D to F, which is sum of DE and EF. So you need to add both the arcs. So first we need arc EF. So how we can get arc EF? So arc EF is inscribed by the central angle, which is 70 degree. So its corresponding intercepted arc will also 70 degree. So here you will mention that major arc EF is same as angle ECF. Reason will be same, central angle, and ECF is of 70 degree. So here you can take 70 degree. Now we need to find out major arc DEF. So DEF is actually equal with major arc DE plus major arc EF. So this major arc DE we just calculated as 90 degree. So here I'll take 90 degree, and this EF is 70 degree. So plus 70 degree. So 90 plus 70 is 160 degree. So this way we can find out both the arc DE is 90 and DEF is 160 degree. And this is your solution for this question number 1. Hope it is clear to everybody. Yes. Okay. So this chord RS. So I'm talking about this chord RS is congruent with QS. So these two are congruent chords. Why? We need to provide proper reason for this, because triangle QRS is an equilateral triangle, and we know all three sides of an equilateral triangle is equal. So here we will mention triangle, or you can simply say property of an equilateral triangle. Property of an equilateral triangle. If these two chords are equal, then their intercepted arc will also equal. So this RS inscribing the arc RS will also congruent with arc QS. Reason is congruent chords inscribe congruent arcs. If two chords are congruent, the arc inscribed by them will also congruent. So this is my first proof. Similarly, we can prove that this QS and QR, these two sides are also equal. So their uh, intercepted arc that is QS and QR are also equal. So similarly, we can prove that arc QS is congruent with arc QR, and this will be your second proof. So from 1 and 2, you can say therefore arc RS is congruent with arc QS, and which is congruent with arc QR. So this way all three arcs are congruent, because all three arcs are inscribed by congruent chords, and those congruent chords are three sides of an equilateral triangle, that is QR, RS and QS. These are three sides, and these are three congruent chords which we are taking in our solution. So if chords are congruent, then the arc made by those congruent chords will also congruent. So this property we have discussed. So we can use this property to prove this first part of the question. Now second part of this question is about major arc QRS is of 240 degree. So this we need to prove that QRS is of 240 degree. Now if triangle in triangle QRS, can I say angle Q is equal with angle R is equal with angle S, and all three angles is of 60 degree. This is one of the property of an equilateral triangle, that all three angles of an equilateral triangle is of 60 degree. So again you can mention property of an equilateral triangle. Okay, so if these three angles is of 60 degree, now come to this, we need arc QRS. So I'll begin with arc QR. So here we can say major arc or angle, we talking about this arc QR. So this is the intercepted arc of this angle S, and this angle S is actually inscribed angle. So here we can say angle S is half of major arc QR because of inscribed angle theorem. So this angle S is of 60 degree. We just proved angle S is of 60 degree. So here we can take 60 is equals to 1 by 2 into major arc. This session is going to expire. In next class we shall complete this.